Today we're going to be working on finding the derivatives of some transcendental functions, and we're going to be using trig functions and ln functions in our derivatives. So let's start with problem number 1. Number 1, we have y equals sine 5x. So since we're working on the derivative of sine x, we know that the derivative of sine x is going to be cosine u du dx. So let's write it down. Cosine u times du dx. And in this particular function, u is 5x and du dx is going to be 5. So if we're going to apply the formula for the derivative function of sine 5x, y prime is therefore cosine 5x multiplied by 5. So this is our derivative for sine 5x, which we can simplify or have other version as 5 cosine 5x. So this is how we use the derivative formula for sine 5x, and now we use chain rule in the process. Now let's go ahead and answer problem number 2. And in number 2, we're looking for the derivative of tangent 3x squared. So the derivative of tangent u is going to be secant squared u du dx. So y prime is secant squared u times du all over dx. So we know that u is 3x squared, and du dx, or derivative of u with respect to x, is going to be 6x. So if we're going to substitute it to our derivative formula, y prime is therefore secant squared u, which is 3x squared, times 6x. Or we can rewrite it as 6x secant squared 3x squared. So this is our derivative function. Now for problem number 3, let's have y equals the square root of secant 5x. Let's rewrite this into secant 5x to the 1/2, so we can use the chain rule, and then the rule for finding the derivative of secant u du dx for this function. So y prime will be 1/2 using the chain rule times the derivative of the inside, which is secant 5x. So we're finished with the derivative of our u to the 1/2. We just need to find the derivative of secant 5x, wherein we know that the derivative of secant u is secant u tangent u du dx. So this is secant u tangent u times du dx, where u is 5x and du is 5. So using the formula, we'll have secant 5x times tangent 5x multiplied by 5 for our derivative function. So our y prime, this is our first set and this is our second set, will be 1/2 multiplied by 5 is our derivative function. And if you want to further simplify this, since this is a negative exponent and it's 1/2, we can modify this into a fraction and the radical form of our secant 5x. So we'll have 5 secant 5x tangent 5x all over 2 square root of secant 5x. So this is now the other version of our derivative function on problem number 3. Now for problem number 4, we have f of x sine cubed 4x. So we can rewrite this in form of f prime of x, f of x, because we're not doing derivatives yet, is sine 4x to the third power. So this is the modified version of our trig function, where we are going to be using the chain rule for our derivative. So f prime of x, so now we're doing f prime of x, is 3 times sine 4x squared multiplied by the derivative of the inside, which is sine 4x. So we're finished with this already. We just need to find the derivative of sine 4x. And we know the derivative of sine 4x is equal to cosine u du dx. So cosine u du dx is our derivative formula, wherein u is 4x and du dx, or the derivative of u with respect to x, is simply 4. So we'll have cosine 4x times 4. So this is our derivative for sine 4x, and from our chain rule, our f prime of x is going to be 3 sine 4x squared. So f prime of x is 3 quantity sine 4x squared times 4 cosine 4x. And if you want to modify this, we can also rewrite this as 3 sine squared 4x multiplied by 4 cosine 4x. And since this and this can still be multiplied, f prime of x can also be 12 sine squared 4x times cosine 4x. So these are some of the versions that you can use in writing out your derivative function, all of which are pretty much the same. And now for the last problem, number 5, we have the derivative of ln, or the function in terms of ln. So number 5 is y equals ln 3x minus 4x squared. So we know that the derivative of ln u with respect to x will be 1 over u times du dx. And this is what we're going to be using in finding the derivative of this transcendental function. So y prime is equal to 1 over u times du over dx. Now we just need to define what u is, and here u is 3x minus 4x squared, and the derivative of u with respect to x will be 3 minus 8x. So by plugging it into our derivative formula, y prime is 1 over u, which is 3x squared minus 3x minus 4x squared, times du dx, which is 3 minus 8x. You can modify your answer and rewrite it as 3 minus 8x all over 3x minus 4x squared. And this is how we find the derivative of some transcendental functions using chain rule.